Hello, good morning viewers. Still on to how to solve differential equations using Laplace transform. Here is our second problem. Remember, I have extended the first class because it was an introductory class. So in today's tutorial, I'm going to rush you a little bit. Okay, we want to find the solution to y double prime plus 5y prime plus 6y equal to 0, and we are given initial conditions here. Y of 0 equal to 2 and y prime of 0 equal to 3. The first thing to do here is to take the Laplace transform of each of these terms. So we have Laplace transform of all of this. Let's start with y prime prime. The Laplace transform of y double prime will be s squared multiplied by the Laplace transform of y. Then minus the power of s will reduce. We have s, y of 0, then minus y prime of 0. Then we have plus, then we take the Laplace transform of the second term. We factor out 5, but taking the Laplace transform of y prime will give us s multiplied by the Laplace transform of y, then minus y of 0. Moving on, we have the third term here, plus 6 multiplied by the Laplace transform of y. And to the right hand side, we have 0 because the Laplace transform of 0 is equal to 0. Okay, let me expand this bracket here. We have s squared multiplied by the Laplace transform of y minus s multiplied by y of 0, which is equal to 2 from here, minus y prime of 0, which is the same thing as 3, plus 5 multiplied by s multiplied by the Laplace transform of y, minus again 5 multiplied by y of 0, but y of 0 is equal to 2. Then we have plus 6 multiplied by the Laplace transform of y, and to the right hand side we have 0. Let's further simplify this. S squared multiplied by the Laplace transform of y minus s times 2 is 2s. We have minus 3 here and we have minus 10 here. Together we have minus 13. Minus 13 plus 5s, the Laplace transform of y. Then the last one we have plus 6 times the Laplace transform of y. To the right hand side we still have 0. Next, let us bring all those that contain Laplace transform together. We have x squared here multiplied by the Laplace transform of y, and we have another one here, plus 5s multiplied by the Laplace transform of y, then plus 6 times the Laplace transform of y, and I want to take all other terms to the right. We have negative 2s. If it crosses over, it becomes positive. We have 2s. And we have negative 13 here. To the right, it becomes 13. All right. Now let us factor out Laplace transform from each of these 3 terms. We have s squared plus 5s plus 6 from each of these terms. All of this multiplied by the Laplace transform of y. To the right hand side, we still have 2s plus 13. Now to have Laplace transform to the left, we can divide both sides by s squared plus 5s plus 6. So the Laplace transform of y to the left, and to the right we have 2s plus 13 divided by s squared plus 5s plus 6. Okay, the denominator can be factorized, so let us do that. The Laplace transform of y is now equal to 2s plus 13 divided by s plus 2 multiplied by s plus 3, because that is the factorized form of s squared plus 5s plus 6. Okay, this is what we have to resolve into partial fractions, and this will be equal to a constant divided by the first factor, s plus 2, plus another constant b divided by the second factor, s plus 3. Okay, this is what we need to solve first. So now let us clear the fractions by multiplying both sides by these two factors. If you multiply the left hand side by the two factors, you have only 2s plus 13. And to the right hand side, taking this, multiplying by this, you have only s plus 3 left multiplied by a, so we can multiply them directly. A multiplied by s is as, plus a multiplied by 3 is 3a. Then we add, we take this, multiply by this again. We will have s plus 2 left multiplied by b. Therefore, b multiplied by s is bs, plus 2 multiplied by b is 2b. 2s plus 13 is equal to, let us bring those with s together. We have as, we have bs. We can factor out the s. So we have a plus b, then multiply by s. Then our constants, we have 3a plus 2b. Now we are going to solve this equation by relating the coefficients. The coefficient of s to the right is a plus b, so we have a plus b. That is equal to the coefficient of s to the left, which is equal to 2. All right. The constants, we have 3a plus 2b to the right, and to the left we have 13 as our constant. Okay, from the first equation you can see that a is equal to 2 minus b, and we can substitute the value of a in the second equation to get the value of b. So let's do that. 3 multiplied by a, which is 2 minus b, then plus 2b. This is equal to 13. Let's distribute. We have 6 minus 3b, then plus 2b equals 13. Negative 3b plus 2b is negative b, so we have negative b to the left. If you take this one to the right, it becomes negative. We have 13 minus 6, which is equal to 7, and this is equal to 7. Therefore, b is equal to negative 7. Okay, if b is equal to negative 7, we can bring it back here to get the value of a. From here, a is equal to 2 minus 7, and a is equal to 9. A is 9 and b is negative 7. We are going to plug them back into this expression. The Laplace transform of y will now be equal to a, which is 9, divided by s plus 2. That is our first factor. Then minus 7 divided by the second factor, which is s plus 3. Remember, we are looking for y, so now we are free to take the inverse Laplace transform of both sides. If you take the inverse Laplace transform of this, the inverse Laplace transform will cancel the Laplace transform, leaving only y. So to the left, we have y. And to the right hand side, we have 9 multiplied by the inverse Laplace transform of 1 divided by s plus 2. I just factor out the 9. Then minus 7 multiplied by the inverse Laplace transform of 1 divided by s plus 3. Okay, from our table, let's go to the table. From our table, this is very important. Look at it here. It says that the Laplace transform of e to the at is equal to 1 divided by s minus a. Okay, let me write it here. The Laplace transform of e to the at, but this time around I will write x because our function is in terms of x. It says that this is equal to 1 divided by s minus a. But from our own expression, we have plus instead of minus. So we can change this to the Laplace transform of e to the negative ax equals 1 divided by s plus a. Right? This means that if you take the inverse Laplace transform of 1 divided by s plus a, you're going to get e to the negative ax. So that's what we need to substitute here. Finally, y is equal to, this is 9 multiplied by this, and this is going to be equal to e to the negative 2x because a is equal to 2 in this equation. Minus 7, this is going to be e to the negative 3x. E to the negative 3x. And hence, this is our solution for that differential equation. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues. And don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.